In my other video on how to compare fractions to see which might be larger or smaller, we looked at how sometimes you can do that using pictures and other times you can do it using times tables. And I'm going to show you how you can do it using times tables. Now, sometimes you can look at what you've got and see a link between the fractions. If you watched the other video, you'll know that the really important thing that we need to do when we're comparing fractions is make the denominator the same. It's not easy to work out whether a half is the same as 2/5 or 2/10 because all the denominators are different. And the denominator is how many pieces something split into. So for example, if I had a cake and I split it into 4 pieces, then my pieces are a different size to if I split it just into 2 pieces, let's say. And so it's really important that I make the denominators the same size so that I can properly compare them. So if I was doing this example, I might look at these and I might say, right, at the moment I've got as my denominators a 2, a 10 and a 5. I want them all to be the same. Start by asking yourself whether the other numbers go into the biggest one. So my biggest one is 10. So could I put 5 into 10? Yep, 5 does go into 10. 10 is in the 5 times table. And does 2 go into 10? Yes, it does. So 10 is the denominator that I'll use. So everything's going to change to tenths. So if I'm using that, then that can stay the same because it's already tenths. If I'm trying to change 1/2 into tenths, I need to think about how I got from the half, the 2, to the 10. So to get from 2 to 10, I have to be timesing by 5. And if I'm going to do that here at the top, I would have to do the same. So I'm timesing by 5, so 1 times 5 is 5. So whatever I do to the denominator to get to my new one is what I have to do to the numerator. 2 times 5 was 10, so 1 times 5 is 5. So I now know that 1/2 is the same as 5/10. And then over here, I'm using tenths again because I want my denominators to all be 10. But this time, because it started as 5, I actually had to just times by 2, which means I have to do the same up here as well. So 2 times by 2 would give me 4. So now what I've got is I've got fractions that say 5/10, 2/10 and 4/10, and I could think, right, if I'm putting them in order from smallest to largest in ascending order, my first one, the smallest, would be B. So my order would go B, and then the next one would be C, and then the final one would be A. So I've now put them in order based on the new denominators. Let's look at another example. So this time, same again. I start by looking at the biggest one, the biggest denominator, and seeing whether the others go into it. Does 4 go into 12? It does. Does 3 go into 12? It does. So my 12 is what I'm going to use. C is exactly the same because it's already got a 12 as the denominator. For A, if I'm doing 12, I'm thinking, right, 3 times what was 12? So 3 times by 4 gives me 12. And I then have to do that to the numerator as well, which gives me 4 because 1 times 4 is 12. So I've made sure I followed the rule that whatever I'm doing to the denominator to get from here to here, I've also done it to the numerator. So 3 times 4 was 12, 1 times 4 is 4. So 1/3 is the same as 4/12. Now for this one, I'm also trying to get to 12, but I start with 4. So to get from 4 to 12, can you see what I times by? I times by 3. So 4 times 3 is 12, and I have to do it to the top. So 3 times by 3 is 9. So now I've got my 3 fractions which all have 12 as a denominator. I've got 1/12, 9/12 and 4/12. I want to put them in ascending order from smallest to largest. So my smallest is C, my next one is A, and my final one is B. But what about a situation where you look for your largest denominator, maybe in this case 9, and you think 3 goes into 9, but 6 doesn't. 9 is not in the 6 times tables. So I can't do 6 times anything to get to 9. So this time we need to think of a number that is in the times tables of all of those. Now you're just going to have to use your times table knowledge for this. There is no magic trick. I can think to myself, right, what do I know about numbers? I know that in the 3 times table, I've got 3, 6, 9, 12, keep going. And 9 has got 9, 18, 27. I think it through. 6 has got 6, 12, 18. And actually, the more I think about it, the more I realise that a number which is in all of these times tables is 18. So I can use this number, 18, as my denominator. I know that because I know my times tables, which is why you have to know your times tables. Get on Times Table Rockstars if you feel like you're not very confident. The better you are at times tables, the easier this stuff will be. So I know that 18 is a number that each of these goes into. So I need to now think, right, to get from 3 to 18, I've timesed by 6. 3 times 6 is 18, so I do 2 times 6 for the numerator. 9 times 2 was 18, and I have to do the same to the numerator. So 3 times 2 is 6. And 6 times 3 is 18, so I do the same to the numerator. 1 times 3 is 3. Now I'm in the same position as I was in the last questions. I've got 18 as my denominators. I just need to put them in order. My smallest is C. Then my next one would be B. And finally it's A. Let's look at one more like that before you have a go at the questions for yourself. So here I've got the number 6, the number 4, and the number 2. I can think of numbers that go into them. Now there might be more than one option. You might think, oh, I could do 24. Yep, you could, because 6 times 4 is 24, and 2 goes into that too. But I'm actually going to use 12, because I think it's slightly easier, slightly lower number, and I know that 6 goes into 12, so does 4, and so does 2. So if I'm using 12 as my denominator, and I'm starting with 6, to get from 6 to 12, I've doubled it. So I do the same up here. 1 doubled is 2. To get from 4 to 12, I'm multiplying by 3, so I do the same up to the top. 3 times 3 is 9. And to get from 2 to 12, I'm timesing by 6. So 2 times 6 was 12, and I do the same for the top. 1 times 6 is 6. And now all it leaves me to do is put them in order from smallest to largest. So the smallest is A, the next one would be C, and finally it's B. There you go. Have a go yourself.